Imagine rewinding the universe. Galaxies rushing backward, stars folding into darkness, planets vanishing into specks, and finally, everything you see, everything you know, collapsing into a single, unimaginably dense point. One moment, it's silent. The next, boom. From that one instant, 13.8 billion years ago, space, time, matter, and energy were born. This is the story of how everything began. Welcome to the Learning Studio, and in today's episode from our physics series, we'll uncover the origin and evolution of the universe, the Big Bang cosmology. You can watch the entire playlist by clicking the link below in the description. What is the Big Bang? The term Big Bang doesn't mean an explosion in space, it means an expansion of space itself. In the beginning, the entire universe was compressed into an incredibly hot, dense state, smaller than an atom, yet containing everything that would become galaxies, stars, and us. Then, in a fraction of a second, space began to stretch and cool. Matter formed. Light burst free. The first atoms of hydrogen and helium came into existence, the building blocks of everything. The first billion years. As the universe expanded, it wasn't just getting bigger, it was evolving. Tiny fluctuations in that early soup of particles became the seeds of galaxies. Gravity began to pull matter together, igniting the first stars, which then fused heavier elements inside their fiery cores. When these massive stars exploded as supernovae, they scattered those elements across space, giving birth to new stars, new planets, and eventually, life itself. In other words, the iron in your blood and the calcium in your bones were once part of a star. You are, quite literally, made of stardust. The expanding universe and its mysteries. In the 1920s, astronomer Edwin Hubble discovered that galaxies are moving away from us, and the farther they are, the faster they move. This was the evidence that the universe is still expanding. But here's where the story gets even more mysterious. Scientists discovered that something invisible is driving that expansion faster and faster. We call it dark energy, a force we still don't fully understand, but it makes up about 70% of the universe. Alongside it, there's dark matter, invisible, untouchable, yet responsible for holding galaxies together with its gravitational pull. Without dark matter, the stars would simply drift apart. Together, dark energy and dark matter shape the fate of the cosmos, yet they remain two of the greatest unsolved puzzles in physics. Why it matters today. You might wonder, why should I care about what happened billions of years ago? Because the story of the universe is the story of us. Understanding cosmic origins helps us model data across astrophysics, predict cosmic radiation, train AI systems to read telescope data, and even simulate the birth of new galaxies. It's not just ancient history, it's the foundation for the future of science, technology, and computation. From a single spark, the universe unfolded into infinite complexity, galaxies, stars, planets, and eventually, conscious beings trying to understand their own beginnings. And that's exactly what physics helps us do, to turn wonder into understanding. So the next time you look up at the stars, remember, you're not just observing the past, you're seeing a story that began 13.8 billion years ago. And continues through you. This is the Learning Studio, and this was our first episode on the origin and evolution of the universe. If you enjoyed this journey, make sure to subscribe, hit the bell icon, and continue exploring the universe with us in the next episode, The Fundamental Forces and Particles, the Building Blocks of Reality. Because in physics, every question leads to a deeper universe.